Student, till now we had completed exercise 2.3 and today we are going to start with exercise 2. Okay, so the first question of exercise 2, the relation f is defined by fx equal to x square, 0 less than x less than equal to 3, 3x if it is 3 is less than equal to x is less than equal to 10. And the function g is defined as gx equal to x square when x is 0 is less than equal to x is less than equal to 2, and 3x when 2 is less than equal to x is less than equal to 10. Now you have to show that f is a function and g is not a function. Now what we had studied, according to the definition of the function, every element of the domain must have one and only one image. Then you will say that as a function. Okay, so see, when I take this f, okay, see there are two functions. Here first, fx is equal to x square when 0 is less than equal to x is less than equal to 3. Clear? And another is, I can split it in two parts, 3x when 3 is less than equal to x is less than equal to 10. Clear? So if I take the values, let's say values 0, 1, 2, 3, 4, 5 and up to 10. See, it's not that I can only take this value. I can also take the value 0.5. Okay, because it is x is greater than equal to 0 and less than equal to 3, so I can also take the decimal values. Okay, so now what is fx? Now see, till here less than 3 you have to use this function, so 0 square 0, 1 square 1, 2 square 4, 3 square 9. Clear? Now here also it is given 3 is less than equal to, so for 3 I can take both the function, this as well as this. Now if I will use this function, then 3 into 3 again it will be equal to 9, right? When I will take 4 now greater than x, I have to use this. 4 3s are 12, 5 3s are 15, up to 10 3s are 30. Now see, for every element there is only a single image. You can see here single image. That can be, you can take also 1.5, then here it will be square of 1.5, right? Its value will be between 4. So for every value of x there is one and only one image, right? For every value of x belonging to domain of function there is one and only one image. So that implies f is a function. Clear? Now when I take g of x, so now what is g of x? First x square and second 3x. When it is x square, when 0 is less than equal to x is less than equal to 2, and here 2 is less than equal to x is less than equal to 10. So for this function, if I take values from 0, 1, 2, 3, 4 up to 10, I can also take the intermediate values between 0 and 1. Now what is fx? When x is 0, we will use this function, 0 square 0, 1 square 1. Now when x is 2, here also 2, here also 2. See, the sign is greater than equal and here also it's equal. So I can use both. If I use this, it's 2 square 4. When I use this, then 3 2s are 6. Then 3 3s are 9, 4 3s are 12, up to 30. Now if I take this case, right, means f of 2, it is having two values, 4 and 6. Therefore, for 2, there are two images, right? Therefore, G is not a function. Clear? And f is a function. Clear? So just note down question number 1. Now let's move to question number 2. Here it is given if fx is equal to x square. See, it is clearly given f of x is equal to x square, and you have to find this f of 1.1 minus f of 1 upon 1.1 minus 1. Clear? So see here. Now see, f of x is x square. That means f of 1.1 will be 1.1 square. So it's 1.1 square. F of x square, f of 1, 1 square. Upon 1.1 minus 1. Here, now see, what is this? Here, this is, you can a square minus b square. A minus b, a plus b, right? So when you will use that, I will get 1.1 minus 1, 1.1 plus 1. On denominator it is 1.1 minus 1. Clear? So what will happen? 1.1 minus 1 and 1.1 minus 1. It will get cancelled. So this will be equal to 1.1 plus 1. 1.1 plus 1. So this will be equal to 2.1. Clear? So note down question number 2. Okay, let's move to the third one. Question number 3. Find the domain of the function fx equal to x square plus 2x plus 1 upon x square minus 8x plus 12. Now remember what you have to do in this type of question. Domain means which value of x you can take. Now you can take any value of x such that this function is defined, right? So this function should not be undefined. So you have to just find out for which value of x this function will be undefined, and that value of x you will not be able to take. So now you know in fraction the denominator cannot have the value of 0, right? Denominator cannot have value of 0, because if it is having a value of 0, that means that function will be undefined, right? So let's find out where this function is having a value, or where the denominator is having the value of 0. Okay. Okay, so now see, let's take x square minus 8x plus 12 equal to 0. Now the value of x that I will get, that value I cannot take. So now just you have to rationalize it. You just make the factors. You have to factorize it. Sorry. So minus 8x and 12. You know 6 2s are 12. Okay, minus 6 and minus 2, it will be equal to plus 12. Minus 6 minus 2 minus 8. When your product is plus 12. So I will find out x square minus 6x minus 2x plus 12 equal to 0. I will take x common here, x minus 6. I will take minus 2 common here. So x plus minus minus 6 equal to 0. That means x minus 6, x minus 2 equal to 0. So what does this imply? Either x minus 6 equal to 0 or x minus 2 equal to 0. So that means either x is equal to 6 or x is equal to 2. Okay, so these are the two values. where the denominator becomes 0 and function becomes defined. So you can take every value of x except 6 and 2. So I will say that domain of function R means all the value minus 2 and 6. See, this means that R all the value, and from that side you have to eliminate 2 and 6. Means you cannot take 2 and 6. Yeah. So this is our answer. Okay. So just note it down. Now let's move to question number 4. Find the domain and range of the real function f defined by fx equal to square root of x minus 1. So here the function given is fx equal to square root of x minus 1. Now see, domain, which value of x can we take? Remember, square root of negative number is not possible. So that means x minus 1 must be always greater than equal to 0. So this means that x must be greater than equal to 1. Right? So we can take any value of x which is greater than equal to 1. So the domain of the function is, we will take the starting value as 1. We can take 1, so close bracket. We can take any number greater than 1, so up to infinity. And for infinity, we will always use open bracket. So this is the domain of the function. Here. Now for the range. Now see, whenever you need to find out the range, take this fx as y. Then find out which value of y can you get such that you take x greater than equal to 1. Now say y is equal to square root of x minus 1. So taking square on both the sides. So y square will be equal to x minus 1. Clear? Okay. So now what will be x? X will be equal to y square plus 1. Now what is x? We have to take the value of x greater than equal to 1. That means y square plus 1 must be greater than equal to 1. Clear? So here 1 will get cancelled. Right? So the value of y square must be greater than equal to 0. Now we know that the square is always positive, right, or 0. So we can take any value, we can get any value of y. Its square will be always greater than equal to 0. So that means that the range of the function is equal to r. So whatever value of x we take which is greater than equal to 1, okay, you can get your answer belonging to real number r. So the range of function is r. Clear? So note down question number 4. Note down question number 4. Now let's move to the next one, that is question number 5. 5. Now question number 5 is find the domain and range of the real function defined by fx is equal to x minus 1. Okay, now see here it is given that fx is equal to modulus of x minus 1. Right? So now first domain. Now see when you will see here, you clearly say that you can take any value of x because modulus function, okay, here it is a modulus function and also it is not in the form of fraction, right? So it will never be undefined. You can take any value of x. So this means that domain of the function will be equal to r. You can take any value. Clear? Now range of the function. Now see x minus 1. When I take y equal to modulus of x minus 1. What is y? Fx. Now this clearly shows that modulus function, whatever value of x you take, that will be always greater than equal to 0. Modulus will be positive, but if I take x equal to 1, then 1 minus 1 0. At that time it will be equal to 0. But it cannot have negative value. So from this we can say that the range of the function is always positive. I can write it down as r plus union 0. R plus means all the positive real numbers. Union 0. Or I can also write it down in this way. Rf minimum value is 0 to infinity. Clear? So note down question number 5. Now let's move to question number 6. Question number 6. Let f equal to x and x upon 1 plus x square. X belongs to r. Be a function from r into r, means from r to r. Determine the range of f. Okay, remember when I am writing like this way, a b, that means b is equal to f of a, means this is the value of the domain and this is the function of a. Clear? So now see here, what I can see here, I can see that here it is x, right? Here I can see x. So what is this? F of x. So here f of x will be equal to x square upon 1 plus x. Now you are being asked that which you are being asked to find out the range of f. Clear? Now, so what I will do, I will take y equal to x square upon 1 plus x square, right? Whenever we want to find out the range, we are doing in this way. Clear? Now remember, x square can never be equal to, this value can never be equal to 0, right? Because it is 1 plus x square. X square is always positive, and any number added to 1, any positive number added to 1, that will never make it 0. Clear? So now cross multiply it, that is y into 1, y plus yx square equal to x. Clear? Now I need to find out the formula for x. So y equal to x square minus yx square. Okay, so y equal to x square common 1 minus y. What will be x square? X square will be equal to y upon 1 minus y. So x will be equal to square root of y upon 1 minus y. Right? So this shows that y cannot be equal to 1. Reason, if I take y equal to 1, then 1 minus 1 equal to 0. And we know that the denominator cannot have the value of 0. Right? So y it's not equal to 1. Okay. Now see, this is a square root. X is equal to square root of y upon 1 minus y. Now we know that square root is only possible if the function inside the square root is greater than equal to 0. So what does this imply? Y upon 1 minus y. This must be greater than equal to 0. Okay, then only it is possible that square root of this can be taken, because square root can never be negative. Clear? So now, when a fraction, if I say a by b is positive, okay, so what does that mean? Either a and b both are positive or a and b both are negative. Because if both are negative, then minus minus sign will get cancelled in the numerator and denominator. So final answer will be plus, or else both will be positive. So now here it is given that y upon 1 minus y is greater than equal to 0. So either y is greater than equal to 0 and 1 minus y is greater than equal to 0. This is the case, or y is negative and 1 minus y is negative. Clear? Okay. So now see here, 1 minute. I will not take here greater than equal to 0. I can only take greater than 0 because it cannot be equal to 0. So this means y is greater than equal to 0 and 1 is greater than y. Here, or I can write down, I can also write down this way, y is greater than equal to 0 and y is less than 1. So what does this means? From 0, I can take the value 0 until 1. The number is y is greater than 0, greater than equal to 0 and less than 1. In this case, y is less than 0 and 1 is less than y. Y is less than 0 and y is greater than 1. Now, is it possible that y is less than 0 and greater than 1? Is there any number which is less than 0 and greater than 1? No. So this is not possible. Here, so what does this imply? This implies that range of function, which is the start with 0 and I will not say end at 1, I will take open bracket. It is less than 1, but I cannot take equal to 1. So this is the range of the function. Yeah, so just note down question number 6. Okay, students, so that's it for today. In our next video lecture, we will start with, or we will continue this exercise. We'll start with question number 7 and complete this exercise. Thank you.